All right, let's talk about exponential growth and decay. That's actually pretty common terms as of late. So real world applicable here. I feel like I've used that word in a lot of my videos today. So what does that look like? What's the difference? What's happening? When do I know which one is which? So if A is greater than 0 and B is greater than 0, then the function is increasing. So that's called an exponential growth function. The base B is its growth factor. So that's kind of vocab heavy there. Growth function, growth factor. So what's an example? So let's say that I have f of x equals 3 times 2 to the x. A is greater than 1, or sorry, A is greater than 0. B is greater than 1 because it's 2. So what that means, think about a little table here. If I had a negative number, so if I had negative 1, my output would be, let's see, 3 times a half, which is 3 halves. If I had 0, 2 to the 0 power is 1, times 3 is 3. If I had 1, 2 to the first power is 1, times 3 is 6. So thinking about those numbers, 0, 3, negative 1, 1.5, and 1, 6. That is a growth. Notice, no matter how big my negative number, how small I guess I should say, my negative number is, so like if it's negative 100, that's still going to be a really tiny decimal. So I'm never going to approach 0. I'm going to approach it. I am never going to actually get to 0. So that, when it never touches like that, that's how I get an asymptote. That's called a horizontal asymptote. Shocking, since it's horizontal, right? Horizontal asymptote is y equals 0. Okay. The domain, notice I could plug in a negative. I could plug in 0. I could plug in a positive. Fractions work as well. That means my domain is negative infinity to infinity. I can also look at that graph and realize that it's going left and right forever. So that works as well. My range, we just kind of talked about this. It's getting real close to 0, but never actually touching it or going below it. But it is going up forever. Up forever is infinity. It's also really easy to see on that graph. Exponentially, if something is growing exponentially, you are making lots of money off of it. Or if it's like bacteria growing exponentially, then all of a sudden there's a whole lot of it when there wasn't very much to begin with. So that's the idea there. You can also have exponential decay. So carbon dating uses the decay factor to decide how old something is. That happens when you still have A greater than 0, but your B is less than 1. Okay? So what does an example look like? Let's call it G of X instead of F of X, just to say that it's different. And let's do 5 times 1/2 raised to the x. So notice your first number is larger, your second number is a fraction that is less than 1. So when I say a fraction, I don't mean 3 halves because that's actually bigger than 1. I mean 1/2. Okay? And so same idea. Think about a little table here. If I had negative 1, that's actually 2. 2 times 5 is 10. If I had 0, 2 to the, or 1/2 to the 0 power is 1, times 5 is 5. And then if I had 1, 1/2 to the first power is 1/2, times 5 is 5/2, which is 2.5. That 2.5 is a little easier to graph. Okay, so my graph would look something like this. Okay, so again, it's getting closer and closer to 0, but the other way. However, your domain and range is still the same. So you still have an horizontal asymptote at y equals 0, because it's approaching 0 but not touching. Your domain is still going left to right forever, both ways. And your bottom to top is still 0 to infinity without ever touching 0. So still x